All right, so given this as the graph, over here we've got y equals absolute value of x. Sorry, it's bad looking equal sign. And that's the picture that it spits out. Absolute value, remember, is the distance away from 0. So if you take a value that's negative and you take its distance away from 0, you get a positive, which is why the graph of this flips up above the x-axis. So let's take a look at that over on Desmos. So on Desmos, you can use this command ABS for absolute value, and it will create that. Now, what if I take that ABS away? So it's just plain old y equals x. See what I was talking about here? We've got a line with a slope of 1. It goes through the origin, so the y-intercept is 0. But as soon as I do that ABS, boom, that part that was down here now gets reflected above the x-axis. So what they're asking me to do in this part is they're saying, okay, I've got two changes for you. All right, so now inside these absolute value bars, we're going to put a minus sign, and this time we're going to put a 3 in there. And what does it look like? Well, look at that. It moves it over. I should probably just zoom in out. It moved it over 3 places to the right. Well, that's kind of weird because there's a minus in there. All right, well, so back on my picture, you know, I guess if I really wanted to do this nicely, I could just over here to 3. Like this. There we go. Of course, there's arrows on both ends. So it just moved it over right 3. Alright, so let's see what happens when I put in a negative 2. So I got my x minus, now I'm going to put in a negative 2. Now, for those of you who are saying to me, well, Mr. Stailey, isn't that the same as plus 2? The answer is correct. That's the same thing as a plus 2. So, whether you do double minus or y equals absolute value of x plus 2, you're not going to notice a difference between those two things because they are the same. And it does move to the left, too. So that would be left 2. Those arrows, both ends. What happens to the graph as you change the h value? H is a horizontal shift. Now, another word for that is horizontal translation. Okay, I think this is going to be same amount. Let's see if I can get that just typed out. Amount and come on, direction. Given the graph, f of x equals x squared, but we're only looking at a portion of it from negative 2 to positive 2. Hold on a second. Okay, they want me to graph its translation 3 units down. Graph its translation 3 units down. So technically, you're just going to take these points and drop them below. So this dot right here, oops, that's too far, that's 4 units. We want to go down 3 units. Every one of these points is going to drop down only 3 units. And so we can, estimate the best looking shape of the graph that's been dropped down 3 units. State the domain of, well, it says of f of x, that's the original. So the original started out and it went from -2 to 2, and the range was what? Range went from 0 at the bottom to 3 at the top. You can tell it started at 0 and went up to 4. Okay, so 0 to 4. 0, 4, and of course we want brackets on that because it's going from the top and the bottom. All right, now we slid the whole thing down, so that means the domain did not change, but the range did. So the range is now 3 units down, so that's -3 and 1. Now there's some weird looking notation down below. All right, so let's take a look at this. These are, right here and right here, are original, not extra crispy, but original x and y values. Okay? Now you'll notice that this has the same x, but the y value's been changed. So the y is 3 less. So domain stayed the same, which makes sense, because the only thing we changed were the y values. So what they're saying is the new graph is 3 units below the old graph. So it says down here, in general, if g of x is equal to f of x plus k, so you're taking the original and you're adding something to it, then g is a vertical translation of the graph of f. Makes sense. If you're adding or subtracting, it's going to shift it up or down. Okay, we'll go to the next slide. All right, now, what happens if we want to shift this 3 units to the right? Okay, so now take all these dots, move that one over 3, move that one over 3, move that one over 3, so we get this shape. The domain is now from 1 to 5. I'm sorry. What am I doing? I'm writing down, I'm right, the domain is 1 to 5, but I'm putting it on the wrong line. Gee whiz. So the range of the original one was 0 to 4. And the range stayed 0 to 4. So you've got, once again, original x and y, right here. This time, we're doing something this notation does not make sense to me. All right, I did find a mistake. That x should not be an x, it should be an x minus 3 because we are shifting this thing to the right 3 units. So, and to be honest, wait a sec, I gotta think about this again. Okay, I figured it out. It's correct. This is the new y value, and so the new y value they're calling g. And so, now, this language that you think is so strange and weird, and you're like, what the heck is going on here? Why are they doing it like this? What they want you to see is that there's a change on the inside. Now, what does that mean to you? It's horizontal. Now, at first you're going to say to me, well, that says x minus 3, so obviously that means to the left. But look, our picture was to the right. So, that is a little bit confusing, right? It looks backwards. To common sense. And so it's really 3 units to the right, even though it looks like a minus 3. We'll talk about it in class because I'm sure that'll come up. Okay, what's next? Perform the indicated. Okay, so we got an inside. So that's an inside. This one's going to go left 2. Remember how it goes against your common sense? So we're going to go left 2, left 2, left 2, draw the V shape. But this one's on the outside. So that's like the first one we did. That's vertical. It matches your common sense. So that's up 2. So we'll take this point up 2, oops, and this point up 2, and then we'll draw the line. So that's matches common sense. All the vertical ones match common sense. So let's talk about a reflection. We're going to reflect across both axes, but we're going to do it one at a time here. A transformation of a function that flips each point over the blank of the blank in a reflection over the what? Over the axis of reflection? I'm guessing that that's what that means. In general, reflection over the x-axis reflects every point on F to produce the graph of G by sending it on every point on F. Oh, okay. So, what's going to change? Let's think about this. Let's draw a graph here. We've got a point. We're reflecting across the x-axis. We'll call this point xy. And we're going to go across that axis. The same x, but we have the opposite y. So, x negative y. What if, though, what if we were changing it across the y-axis? Then that means the x value would change and the y value would stay the same. So on the next line, it says, in general, a reflection over the y-axis reflects every point on F to produce the graph of G by sending every point xy to negative xy. I really think if you would focus your attention on a picture like this, you would realize what axis you're reflecting across. Okay, so last example, or at least on this page. I think it is the last example, though. Reflecting over the x-axis. So here we have a function, all right? Maybe there's another one, I don't know. 1/2 x plus 1, and they've graphed it for us, but only over the domain -4 to 4. Now the range of that, it goes from -1, from -1 up to a high value of 3. Here, I'll get rid of those little things. All right, now we're reflecting this across the x-axis, so that's the one where the y values change. So this point up here is now going to drop straight down there, and this point up here is going to drop up here, and now we can connect them together. So they did the reflecting. Okay, now we can talk about domain and range. Well, domain stayed the same. Range now goes from -3 to +1. Oh, look what happened there. They flipped and changed signs. Interesting. Very interesting. Down at the bottom, they just show you some notation. Okay, and they want you to prove it by substituting. So they're saying that the new function, they're calling it g of x, is equal to the opposite y value. Opposite y value. That's what this notation means. Opposite y. So, let's see here. That would be the opposite of 1/2 x plus 1. Which, if I distributed correctly, would be -1/2 x minus 1. So that's what g of x is. Well, doesn't that make sense? It's got a y-intercept at -1 and a slope of -1. If we zoom in on that, we can see y-intercept right there at -1, and it goes down 1 over 2, down 1 over 2. So yes, it has a -1/2 slope. So that makes sense. I know that. Hopefully that makes sense, but it probably will take a little bit of time to sink in. Okay, we'll see what else we have here. Okay, we did have one more example here. So, same exact function to start with, but this time we're reflecting over the y-axis. Okay, now the y-axis, that would be, according to our picture that we had there, if you're jumping across the y-axis, that means the xy point becomes -xy, so the x value is changing. Okay, so just the x is changing. So if we have this and we're jumping across the y-axis, right, this point jumps over there, this point jumps over here. And then we can draw the line. Whoops, didn't draw a very straight line, did I? Much better. So the range went from 1 to 3 on the original. When I multiply the x's by -1, the domain, well, wait a sec, isn't it -4 to 4? It's the same thing. And the range is still 1 to 3. Now, that's a little misleading. A little misleading because remember how in the last one, the y's, they not only swapped, they changed to the opposite signs but switched? Well, you're dealing with 4s, so you might not see that. So that's why it looks the same. If it wasn't so symmetric with the y-axis, we would see a change. Now, if we want to come down here and do this algebra, we're going to figure out what g of x is by substituting -x into the equation for x. That means 1/2 times -x plus 1. So we're using this original equation, but we're substituting for x, we're substituting negative x. Well, a little bit of algebra would give me negative 1/2 x plus 1. So take a look at it. See what you got. Do we have a y-intercept of 1? Yes, we do. Do we have a slope of negative 1/2? Down 1 over 2. Down 1 over 2. Yes, we do. So that is correct. That is g of x. G of x is the negative 1/2 x plus 1. So if you want to do a reflection over the x-axis, you change the y. If you want to do a reflection over the y-axis, you change the x. And we will practice that in our homework. See you soon.